Good morning, everyone. We'll start with the subject fluid mechanics. This is for third semester of in civil engineering under VTU. The course code is 18CV33. The internal assessment would be for 40 marks. Semester end examination would be 60 marks. So you'll be getting 3 credits. So in the subject of fluid mechanics, we should know what is fluid. All the substances that exist in the world can be grouped into solids, liquids, and gases. The substances which are in liquid state and the gaseous states are commonly referred to as fluids. Now in this picture, we'll see where all we should know the fluid mechanics concepts and its applications. In this figure, we have a car which will be moving in air on the surface of the ground. So air resistance will be there. So if you want to move the vehicle faster, obviously air will be playing its role on the body of the car. Similarly here in case of aeroplane, which is an object which will be moving very fast in the air itself. So air will be playing a role on the surface of aeroplane. Then comes on the surface of the earth but faster moving vehicles like bullet trains. So it has to overcome resistance of the air. So we should know how the air, that is a common fluid, how it resists the motion of these objects. Now this is a submarine which is inside the water. It has to move, it shouldn't sink. It has to move at a particular level and then it has to maneuver here and there. So obviously the water which is on the surrounding area of vehicle, submarine, how it plays a role uh, as far as the movement of submarine is concerned is a point of interest. The other areas where we should know fluid mechanics are, now in this case I have shown wind turbine. Obviously the blades will be moving in air and then because of movement of air there will be rotation of these blades and once it starts moving the generator inside this body will be generating electricity. So again it is aerodynamics which will be coming into picture. This is also a wind turbine which is or which was used in Netherlands. So these kind of turbines were used to remove the water from enclosed sea and the turbines used to run for years together to empty the water. Here there is a pump or it can also be a turbine, means the water is lifted up or because of the water there will be a rotation. So this is part of the pump which will be shown here. So whenever air or water, which are nothing but common fluids, the objects which will be having a contact of these fluids, obviously we should know the fluid properties and how the forces will be acting on them, or because of the objects, how the force will be acted upon, etc. Here is a case of water. So when the water moves through the rivers, how it moves, will it be moving smoothly or vigorously? It will be eroding anything, or will it be harmful for the surrounding places? If the level of the water rises, how it affects? All this is the movement of water, movement of fluid. And then if you construct a dam across the water, then how the dam has to be constructed. And then if you want to let the fluid out of the dam, how it has to be left on the other side. Aesthetically, it should be beautiful as well as it should be safe enough. So here also there is a dam, and then partially the water is moving out. So the dam is nothing but a structure which comes in contact with fluid, that is water. Here there is cave wall, that is a part of the area is protected from waves. So this is nothing but cave wall, or this is the construction of offshore structure, maybe oil rig or something like that. And then if you want to construct something like that, obviously you should not get affected because of the wave forces. So how to take care of those waves, how to protect our equipments and then people from those waves, etc., is domain of fluid mechanics. So like this, as you have seen just now, uh, wherever there is fluid which is coming in contact with many objects, maybe artificially uh, built structures, maybe equipments, maybe even in case of animals which will be moving inside the water, how the surface is, and then what is the kind of resistance that will be offered by the fluid, that is water, and then how it moves without much of resistance. So all this is nothing but the area where fluid mechanics will be having a major role. You can see that PTU, Shri Technical University, has these course or subject learning objectives or intentions. That what the objectives are. The objectives of this course is to make the students to learn the fundamental properties of the fluids and its applications, hydrostatic laws, and applications to solve practical problems. Number three is principles of kinematics and hydrodynamics for practical applications. Number four is basic design of pipes and pipe networks considering flow, pressure and its losses. Fifth objective is the basic flow rate measurements. Now, these are nothing but short-term goals. By the end of this particular study of fluid mechanics, you should be knowing this. But long-term objective is nothing but to attain or achieve these program objectives. The program is civil engineering. So if you want to get a degree at the end of engineering graduation, the student should be able to get, there are so many, that is 12 objectives passed by Washington Accord. So engineering knowledge, problem analysis, design and development of solutions, conduct investigations of complex problems, modern tool usage, the engineer in the society, environment and sustainability, ethics, individual and teamwork, communication, project management and finance, and lifelong learning. So these are the long-term objectives by the end of graduation one should be able to achieve. So always whenever you learn a subject, you make sure that you achieve short-term goals which are defined as course objectives, and then long-term objectives. At the end of the degree, we should have all these skills developed. Now with those course objectives, I have designed course outcomes. After studying the subject, the student should be able to. There are 6 objectives. Number 1 is summarize the fundamental properties of the fluids, apply the concepts of hydrostatic pressure on immersed surfaces. Second one. The third one is analyze the basic fluid flow kinematics through mathematical models. The fourth one is analyze the force on bends, pressure and velocity in pipes, venturimeter, pitot tube through the fundamental principles of fluid mechanics, that is continuity equation, Bernoulli's equation, and impulse momentum principle. The fifth objective or outcome would be the student will be able to use fluid mechanics concepts for flow through orifice, mouthpiece, notches, and weirs. And the last one, sixth outcome, would be analyze the major and minor losses in pipes, pipes in series, pipes in parallel, and also the transient flow through the pipes. For the subject fluid mechanics, the syllabus is put into 5 modules as usual. So here there is module number 1, which has got 2 parts. You can just see fluids and their properties in the first part, and fluid pressure and its measurements would be the second part. So in my course outcomes, I have taken this whole thing as the first CO, course outcome. So we'll be learning many things about properties of fluids and their measurements, and then in the second course objective will be course outcome. We'll be studying about all these kind of things, pressure, then the laws involved, then how to measure, etc. So first part, system of units. We shall generalize everything that an engineer comes across and talks about. And that is, we can put them as physical quantities. Obviously, an engineer will be coming across many things, and then he wants to measure many things I have listed. There may be many more, but coarsely we can say that we want to know the length, the breadth, height, volume of anything, the mass, inertia, force, weight, that is gravitational pull, maybe temperature, maybe electricity, magnetic field, resistance to electricity, conductance, etc. That is duration, that is speed, acceleration, discharge, so volume rate. Then we have density, specific weight, relative density, specific volume, specific heat, stress, strain, Poisson's ratio, modulus of elasticity, friction, coefficient of linear expansion, pressure, surface tension, viscosity, capillarity, compressive strength, tensile, shear, crushing strength, yield strength, hydraulic conductivity, specific yield, and many more. So these are the things that we will be talking about in engineering overall, or whenever we study mechanics, right? So we should know in what kind of ways how the things are measured. So what we can say is all the physical quantities that an engineer comes across will be expressed through two elements, mainly quality of the physical quantity and quantity of physical quantity. The quality is expressed by what is known as a dimension, and quantity is expressed in terms of what is known as units. What is meant by dimension? We can define it as a characteristic of object, characteristic of a condition, or the order of events, and is described quantitatively in terms of units. And then units may be defined as the standards in terms of which the various physical quantities are measured. Or in short, we can say what physical quantity you want to talk about. If the answer is given, then you'll be talking about a dimension. What is that you want to know? What is that you want to measure? For example, length, for example, area, for example, mass. So these are nothing but dimensions. So it is characteristic of object, condition, maybe a temperature, maybe it is flowing, and then the order of events in the sense the time comes into picture, but which is earlier, which is later, and then how late it is. So like this, what you want to talk about, what you want to talk about, the answer is dimension. Now, how much is that physical quantity? If the answer is given, then you are talking about or in terms of units. So physical quantities, what is that physical quantity? The answer is dimension. How much is the physical quantity? The answer is in terms of units. So this is about dimensions and units. So we have a system of units which are based on the familiar Newton's second law, which is F equal to m into a, force is equal to mass into acceleration. The systems that we know are a metric system, MKS system, in which absolute system will be physicist system, gravitational system would be engineer system. In case of MKS system, we know that it is meter, kilogram, and then seconds. MKS system. For measurement of length is meter. For measurement of mass, it is kilogram. For measurement of time, it is seconds. And then in English system, FPS, that is foot, pound, and seconds. If you come to gravitational or engineer system, it is pounds or slugs and then seconds. Because of the confusion that used to be there between the system of units, at the 11th General Conference of Weight and Measurements in 1960 at Paris, it is decided to adopt a unified, internationally systematically constituted, coherent system of units for international use. It is known as International System of Units and abbreviated as SI units or SI system of measurement. Here length is measured in terms of meters, abbreviated as m. Mass is measured in terms of kilograms, kg, and the time is measured in terms of seconds. Now all these earlier mentioned physical quantities, that is in earlier slides I have shown many physical quantities, and many more of them can be expressed as a combination of very few physical quantities. The simplest example, length is measured in meters, whereas area is measured in meters square, volume is measured in meter cube. So like that, the combination of the dimensions are used to measure or represent physical quantities. So these will be, that is the length, the mass, and the time. These will be obviously referred to as fundamental or basic or primary physical quantities. Again, I want to put an example. If you want to talk about velocity, we know that it is measured in meter per second. Or if you want to talk about acceleration, it is meter per second squared. So we'll be hitting often this meter or kg or second. For example, force, force is measured in terms of mass and acceleration, so it will be kg meter per second squared. But kg meter per second squared will be known as Newton. But try to appreciate that it is kg meter and second squared. So we'll be almost always talk about three physical quantities, and they are namely length, mass, and time, and referred to as fundamental or basic or primary physical quantities, the dimensions of which are L, M, T respectively, and only these will be most important ones as far as civil engineering is concerned. Maybe in some other engineering fields, the other quantities like temperature or resistance, for a matter of fact, may be a fundamental unit for measuring many things. But as far as civil engineering is concerned, we'll be talking in terms of length, mass, and time. The other physical quantities can be referred to as secondary or derived physical quantities. The examples are the force, kg meter per second squared. Another example would be speed, meter per second. So like that, it is a combination of fundamental or basic primary quantities, physical quantities. Okay, in this slide, we'll try to see how other physical quantities other than length, mass, and time, for them, how the dimension is derived or measurement is accomplished. We have primary physical quantities as L, M, T, length, mass, time, the dimensions of which are L, M, and T respectively. Now let us see how to derive the dimension of other physical quantities. We'll start with very simple one. Let us derive dimension of a physical quantity, speed. So general steps, step number one, search for a definition or a physical law involving the physical quantities. In this case, we know that the definition of speed as the distance traveled per unit time. Distance traveled per unit time. So write the expression for the physical quantity, that is speed is equal to distance divided by time. Step number 3, on the right hand side, ascertain that we know dimensions of all the quantities listed there. Now substitute and simplify. Now, speed is equal to distance divided by time. Distance is measured as a length L, divided by time t. So you have dimension as L raised to 1, T raised to minus 1, and mass is not coming into picture. So overall dimension of speed would be m raised to 0, L raised to 1, T raised to minus 1. So this m raised to 0, L, T raised to minus 1 put in square brackets is referred to as the dimension of speed. That is a characteristic way of writing the dimension, that is in square brackets. So hence the unit of measurement for speed would be meter per second, dimension of which is L by T. So like this, any physical quantity if you take, we should be able to derive the dimension. So step number 1, you should try to involve it with physical law or expression. Then write the expression for the physical quantity. Then on the right hand side, all the terms you should be having fundamental quantities. If there is something again a secondary quantity, you should be knowing in terms of primary quantity, and then afterwards you can derive the dimension of any physical quantity for a matter of fact. So thank you.